The National Electrical Code, or NEC, serves as the primary standard for electrical installations throughout the United States. This includes areas like Prince William County, Virginia. It's important to understand that the NEC doesn't have a specific rule requiring a main service disconnect to be placed between the electric meter and the circuit breaker panel, which is also known as the main distribution panel. However, this doesn't mean such a disconnect isn't needed. Local jurisdictions have the authority to modify or add to the NEC requirements through local code amendments. This means that Prince William County could have its own specific rules about main service disconnects that go beyond what the NEC says. To find out if there is a local amendment in place that requires a main service disconnect in this particular location, there are a couple of key steps to take. Firstly, contact the Prince William County Building Inspection Department directly. This department is the best source of information about local electrical code requirements. They can provide details on any amendments or specific rules that apply in the county. Secondly, review the county's Code of Ordinances. This document contains all the local laws and regulations, and it should include any amendments to the NEC related to electrical work. If, after checking with the Building Inspection Department and reviewing the Code of Ordinances, it turns out that a main service disconnect is indeed required, you have several potential actions to consider. Firstly, you can proceed with the installation of a main disconnect. Your electrician can install a suitable disconnect device between the meter and the circuit breaker panel. This will ensure that the installation complies with the local code requirements. Secondly, you could consider appealing the inspector's decision. If you believe the inspector has misinterpreted the code, or if your electrician believes a disconnect isn't necessary based on the specific circumstances, you can submit a written appeal to the Building Inspection Department. In your appeal, clearly explain your electrician's interpretation of the code and the reasons why you believe a disconnect isn't required in this situation. Thirdly, you have the option of requesting a code variance. If your appeal is unsuccessful, you can apply for a code variance from the County Board of Supervisors. This is essentially a request for an exception to the code. However, obtaining a code variance can be a complex and time-consuming process. To be successful, you would typically need to demonstrate that installing a main disconnect would create an undue hardship, or that there are other factors that justify a variance. To effectively address this issue, it's recommended to take these steps in order. 1. Start by contacting the Building Inspection Department to get confirmation of the specific code requirements in Prince William County. 2. If a main disconnect is required, discuss the available options with your electrician. Together, you can decide on the most appropriate course of action, taking into account the cost, time, and potential impacts on the electrical system. 3. If you decide to appeal the inspector's decision or apply for a code variance, make sure you're prepared to provide comprehensive documentation and evidence to support your request. This might include electrical diagrams, code references, and expert opinions. Let's take a closer look at the components of this situation. First, let's define a service disconnect. A service disconnect is a switch or circuit breaker that can be used to shut off all power to a building or a specific electrical system. It's a crucial safety feature that allows for quick and easy de-energization in case of emergencies, maintenance, or repairs. The National Electrical Code, which is updated every 3 years, provides guidelines and standards for electrical installations across the United States. It's designed to ensure safety and prevent electrical hazards. However, the NEC is not a law in itself. It's adopted and enforced by state and local jurisdictions. This is where local code amendments come into play. Local jurisdictions can modify or add to the NEC requirements to address specific local needs or concerns. These amendments can vary significantly from one location to another. For example, one county might require arc fault circuit interrupters, or size, in all bedrooms, while another county might not. In the context of a main service disconnect, a local amendment might require a disconnect even if the NEC doesn't. This could be due to factors such as local utility requirements, specific building types, or historical electrical safety concerns. Now let's consider the role of the Building Inspection Department. The Building Inspection Department is responsible for enforcing the electrical code and ensuring that electrical installations meet safety standards. Building inspectors review electrical plans, conduct on-site inspections, and issue permits for electrical work. If an inspector identifies a code violation, they can require the electrician or homeowner to correct it before the installation is approved. In the case of a disagreement between an electrician and an inspector, it's essential to have a clear understanding of the code requirements. This is where contacting the Building Inspection Department and reviewing the Code of Ordinances becomes crucial. It's also helpful to have a good working relationship with the inspector and to be able to discuss the issue calmly and professionally. An appeal process is a formal way to challenge an inspector's decision. The appeal process typically involves submitting a written request to the Building Inspection Department, explaining the reasons why you believe the inspector's decision is incorrect. The appeal might be reviewed by a senior inspector or a board of appeals. If the appeal is denied, the next step might be to apply for a code variance. A code variance is a request for an exception to the code. Variances are typically granted only in cases where strict compliance with the code would create an undue hardship or where there are unique circumstances that justify a variance. To apply for a code variance, you'll need to submit a formal application to the County Board of Supervisors. The application should include detailed information about the project, the specific code requirement you're seeking a variance from, and the reasons why you believe a variance is justified. The Board of Supervisors will review the application and may hold a public hearing before making a decision. Obtaining a code variance can be a challenging process, and there's no guarantee that the variance will be granted. The Board of Supervisors will consider various factors, including the safety implications of the variance, the potential impact on neighboring properties, and the overall public interest. If you're considering applying for a code variance, it's advisable to consult with an attorney or a code consultant who has experience with the variance process. They can help you prepare a strong application and represent your interests before the Board of Supervisors. Now let's look at the technical aspects of installing a main service disconnect. A main service disconnect is typically a large circuit breaker or a disconnect switch that's rated to handle the entire electrical load of the building. It should be readily accessible to the homeowner or building manager in case of an emergency. The disconnect should be clearly labeled to indicate its purpose. The location of the disconnect is also important. It should be installed in a location where it can be easily accessed, but it should also be protected from physical damage and unauthorized access. The NEC specifies requirements for the location and installation of service disconnects. The size of the conductors feeding the disconnect must be adequate to carry the load. The conductors must be properly sized according to NEC Table 310.16, which provides ampacity ratings for various types of conductors based on their size and insulation. The overcurrent protection for the conductors must also be properly sized. Overcurrent protection is typically provided by a circuit breaker or a fuse. The overcurrent protection device should be sized to protect the conductors from overload in short-circuit conditions. The NEC provides guidance on how to select the appropriate overcurrent protection device. Grounding is another critical aspect of electrical safety. The grounding system provides a path for fault current to flow back to the source, which helps to trap the overcurrent protection device and energize the circuit. The grounding system must be properly installed and maintained to ensure its effectiveness. The NEC specifies requirements for grounding electrodes, grounding conductors, and bonding. Bonding is the process of connecting metallic parts of the electrical system together to create a low impedance path for fault current. Bonding helps to prevent voltage differences between different parts of the system, which can be a shock hazard. The NEC specifies requirements for bonding different types of equipment, such as metal conduits, metal enclosures, and metal water pipes. Arc fault circuit interrupters, or of size, are devices that are designed to protect against arc faults. Arc faults are dangerous electrical faults that can cause fires. F-size detect arc faults and interrupt the circuit, preventing the arc fault from escalating into a fire. The NEC requires F-size in many locations, including bedrooms, living rooms, and dining rooms. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect against ground faults. Ground faults occur when current leaks from a circuit to ground. GFCIs detect ground faults and interrupt the circuit, preventing electric shock. The NEC requires GFCIs in many locations, including bathrooms, kitchens, and outdoor areas. Surge protection devices, or SPDs, are devices that are designed to protect against voltage surges. Voltage surges are brief spikes in voltage that can damage electronic equipment. SPD divert the surge current to ground, protecting the equipment from damage. The NEC recommends SPD for sensitive electronic equipment. When working on electrical systems, it's essential to follow safe work practices. Always de-energize the circuit before working on it. Use appropriate personal protective equipment, such as gloves and eye protection. Follow the NEC and other applicable codes and standards. If you're not comfortable working on electrical systems, hire a qualified electrician. Working with electricity can be dangerous, and it's always better to be safe than sorry. The installation of a main service disconnect can provide several benefits. It allows for quick and easy de-energization of the electrical system in case of an emergency. It provides a convenient way to shut off power for maintenance and repairs. It can improve the safety of the electrical system. If you're considering installing a main service disconnect, it's important to consult with a qualified electrician to determine the best location and type of disconnect for your specific situation. The electrician can also ensure that the disconnect is properly installed and meets all applicable code requirements. Remember, electrical safety is paramount. Always follow safe work practices and consult with a qualified electrician if you have any questions or concerns. The National Electrical Code is a comprehensive set of standards, and it's essential to have a good understanding of the code requirements to ensure the safety of electrical installations. Local code amendments can add to or modify the NEC requirements, so it's important to check with the local building inspection department to determine the specific code requirements in your area. If you encounter a disagreement with an inspector, try to resolve the issue through communication and understanding. If necessary, you can appeal the inspector's decision or apply for a code variance. Electrical work should always be performed by qualified individuals who are familiar with the NEC and local code requirements. The goal is to ensure that electrical installations are safe, reliable, and compliant with all applicable codes and standards.